Hello, and this is an unofficial tour through my contribution to the Leonardo virtual exhibition Slow AI. So this is the main exhibition page. We've got an audio tour, and the exhibition's curated by Eilo, and we have the introduction to the exhibition here. And if we scroll down, mine is the first work we come to, and then we have the other work in the exhibition too as we go further in. So back up to my work in a moment. And my project for this show is called limp.freq, and really it's exploring the hidden or less anticipated, less seen effects of asymmetry, leg length discrepancy, other seemingly local movement related disabilities, and the cascading broader knock-on effects they have on movement through space, and the implications for spatial design, the inadequacies of existing spatial design. Or at least that's how the pieces start out. And they then go from inscribing on virtual spaces to starting to build new virtual spaces of their own. So effectively, my virtual exhibition suite is a series of still images, which we can see here. And these images are the outputs of a series of simulations which run in the browser, and we come across here. And the simulations are roughly in a kind of narrative order, as well as ordered by complexity. There are also a series of 3 short tutorials, although it's possible to just leap straight in. If we click each of these images, it will take us to the live simulation. And there are 6 simulations in total. So if I go back to the main page, all are really concerned with these ideas of asymmetric, limping, wonky, slightly disordered movement and its broader effects on space. And yeah, really the idea comes from my own leg length discrepancy, and the way that its localized effects are quite well understood, or at least heavily noticed, but the larger scale effects are not. At the scales of environmental placemaking and spatial design, the effects are not very well understood or not very well anticipated at all. And throughout these simulations and throughout the images, we see orange bots, a population of orange self-navigating bots and their trails. And these are a standard, efficient algorithm. They go from place to place as quickly and efficiently as possible. And then we have the green bots, which and their trails, and these kind of are based on a sort of twisted, slightly asymmetric motion, more like my own body, although not necessarily an illustration of that in a more sort of generalized form. They're imperfect, and the paths they take are also imperfect. They tend to take more roundabout routes. Their stability is slightly off. But at the same time, this means they get a different take on the world. They sense their shared world differently. And it's this difference in sensing, difference in understanding the shared world, that as the simulations continue through different scales, different environments becoming more complex, that we start to have the bots not only read the world and inscribe their paths upon it, but use the data they've sensed, the information they've sensed, as the starting points for building new worlds of their own. So we see difference in construction between the two kinds of bots, as well as differences in their paths earlier on as we get through the simulations. At the same time, 5 out of 6 of the simulations are freely hackable by the user. These things run in the browser, but they also have inbuilt miniature programming environments, and they can be customized, always completely reprogrammed to the point of failure by the user. And I'm especially interested in whether people emphasize the difference, try and minimize the difference between the bots, maybe even recast the bots in their own image. So these aren't intended as self-portraits or anything like that. They're intended to provoke thought and enable exploration. And that was maybe the most important thing for me, that the user could explore some of these things on their own. At the same time, I'm particularly interested in the early years of AI, when a lot of ideas became, or a lot of directions became set in stone. And the bots, although they are digital, it would be completely possible to make them as physical bots using the technologies of the 1950s, the early 1950s only. It would be possible to make them entirely with vacuum tube technologies, for instance. So at the same time, they kind of imagine an alternative history of AI, one that instead of chasing perfection through abstraction and simplification or oversimplification, and thus ultimately exclusion of asymmetry, of messiness, of imperfection. A history that celebrates imperfection and diversity, and embraces the different kinds of experience and learning that brings. So we have this reasonably long text here. We have the images, the idea perhaps the images pull people in. These are quite high resolution. You can see some of the details. You can see the slightly disordered green paths compared to the more pristine orange paths, as well as them moving in different ways. Some of these have areas where the green bots struggle to go. Others, the spatial representations are, in this one, for instance, the result of the orange bots being able to use stairs, the green bots not being able to use the stairs, only able to use lifts and ramps within a 3D pseudo-built environment. And similar here. And again, in the simulations themselves, we go from 2D spaces to kind of undulating, more complex 2D spaces, to 2D spaces at a larger scale, eventually into 3-dimensional spaces, and then eventually into world building instead of just experiencing and inscribing. Just as importantly, in the documentation section, as well as the tutorials, we also have the link through to the GitHub repository. And as well as running these things from the browser, you can download these and hack these. And there's various kind of guides on how you can freely customize pretty much everything. from the surface level to the rules deeply inside. There's also a snapshot of the kind of process for the particularly interested. All of the in progress materials are captured here as well.